Tes. Yes. Tajuk apa tadi? Astronomy. Astronomy. Okey.
Okey. Okey, tadi dia. Okey. Assalamualaikum. Datang. So kita akan so saya jemput Mr. Halim untuk start.
Okay, bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala Rasulillah wa ala alihi washabihi ajmain. Okay, hari ini our talk is about astronomy for the community basically lah, ringkasnya. Ramai yang bertanya belajar astronomi ni apa faedah dia? Apa yang kita dapat buat dalam masyarakat kan, sebab semua tengok benda atas-atas saja. Well, sebenarnya astronomy started off pun selain daripada curiosity of the universe, ada kepentingan harian. Number one is timekeeping. That the day begins at dawn and then ends at sunset. Contohnya lah, kalau dulu tak ada lampu elektrik apa semua, bila after sunset tu is already gelap. Tak banyak benda boleh buat, orang buat amal ibadat saja. So that's short term. And then in the longer term of keeping time, how old are you? How do you measure the movement of time? What is 1 month? And so on. So that is another dimension of astronomy. Actually, astronomy is very closely related to timekeeping. It may surprise you. You might think that astronomy is about teropong and tengok apa yang ada di sana dan sebagainya, but actually one of the dimensions of astronomy is timekeeping. And a lot of new development comes about when timekeeping has reached a certain level of accuracy. The Europeans dare to travel by sea to go and visit lands and conquer lands after they have mastered the clockmaking technology, because then they connect up with the stars, they can know their position, where on the sea they are. But if you are on the sea, you will know there's nothing to tell you where you are. It's all water. So it's the sky. So that's how it has grown. In ancient times, we have seen Stonehenge. Tahu kan Stonehenge? Stonehenge, people still wonder what it is for. But one of the interpretation is it was set up to see the alignment of the sun and decide when a certain season begins, so that people can tanam apa-apalah yang mengikut musim, because that has something to do with the duration of daylight as well. Same winter daylight is short, summer daylight is long, and so on. We in Malaysia, we may not appreciate this because our day and night is nearly the same. But if you go to higher latitudes, you will know there is seasonal variation on the length of the day. As a result of my talk today, I'm going to relate to how astronomy has been used for calendar for our community. Okay. Today we use the Gregorian calendar that's based on the rotation of the Earth and also revolution of the Earth around the Sun. One revolution is 1 year, okay, and one rotation is 1 day. That has its roots during the time of Julius Caesar, the famous emperor of Rome. However, prior to that, many communities use the moon cycle for measuring time, for measuring month especially. 1 month is from one new moon to the next new moon, or one full moon to the next full moon, and so on. So the celestial object of the moon is a timekeeper as well. It has been a good timekeeper for a very long time. Earlier people, even your great grandparents, are probably very familiar with phases of the moon. Dia tengok bulan macam tu, dia tahu ni bulan tua, ini berapa hari bulan, dia boleh agak lah. Whereas if you use the sun, you tengok matahari, you boleh tahu ke ni bulan apa, berapa hari bulan. Tak boleh kan? You require deeper astronomy to fathom the secrets of the solar cycle. But in between, celah-celah tu, before I go into proper calendar discussion, there is astrology. Pernah dengar? Astrology is ilmu tenung nasib. Kadang-kadang people say ilmu nujum, using astronomy. So at one time, the two things are together, blended. Orang guna astronomy untuk astrology. Dia tengok you lahir bulan ni, matahari ada di sini, you bintang ni dan sebagainya lah. Itu yang terbitnya bintang 12. The 12 zodiacs. Sebab matahari ni dia bergerak di langit mengikut jejak zodiak tu. Jadi kalau kita lahir bulan sekian, dia tengok, oh dia ada dekat Aquarius misalnya. So dia Aquarius. Selain daripada itu, there is also the moon sign. Moon ada di mana pun dilihat, dan planet ada di mana pun dilihat. Macam planet Mars, dia kata apa, God of War. Venus, God of Love. Jadi kedua semua tu dipercayai mempunyai kesan kepada orang yang lahir tu. Of course, today we know that's pretty much nonsensical. Tak ada. We have not been able to establish the link between the position of planets and who you are. Kalau tak semua yang lahir tarikh yang sama tu, sama je lah nasib dia. Tapi seorang dekat Afrika, seorang dekat Somalia duk sedang menderita kebuluran, seorang lagi dekat Malaysia gemuk kan, obese, mengalami nasib yang berlainan. So we put that as kita orang Melayu kita tahyul. Kalau kita kata nonsense jugalah, ataupun kita boleh kata dia duduk di dalam realm kepercayaan. Orang nak percaya, tak mau percaya, tak percayalah kan. So I'm not talking about that. Walaupun itu ada kaitan dengan astronomy. Untuk nak calculate tu, matahari ada kat mana tu? Astronomy, they use astronomy. Masa you lahir tu, Mars ada kat mana? Dia kena ada astronomical calculation. Okay, so back to calendar. There are basically two types of calendar being used. One is, cakap bahasa Inggeris ke Melayu? So saya campur-campur. Satu is purely lunar, calendar Qamari. Kalau bahasa Melayu lah, Qamari. Satu lagi ialah purely solar, 100% bergantung kepada matahari. Tapi in between those two ada satu compromise calendar, dipanggil lunisolar calendar. Okay, siapa pakai yang mana? So kalau solar, purely solar is the calendar we use today lah, the Gregorian calendar. Gregorian calendar ni nama tu datang daripada Pope Gregory. Sebelum Gregory ni, Julius Caesar buat kalender based on solar, dia panggil Julian calendar. Tapi masa tu pengetahuan tentang perjalanan peredaran bumi mengelilingi matahari tidak accurate enough. So after hundreds of years, mereka dapati bahawa macam lari sikit tarikh dengan musim. So Pope Gregory bersetuju untuk cut off 10 hari daripada kalender. 10 hari tu number. Harinya Isnin, Selasa, Rabu tak cut. Isnin, Selasa, Rabu tu continue. Tapi 10 hari hilang daripada kalender. Lepas tu calculation tentang kalender diperbaiki dan dipanggil Gregorian calendar. Even Gregorian calendar pun, selain daripada bulan Februari, setiap 4 tahun ada leap year, tahun lompat kan, tapi secara tak sedar ada leap second juga, tapi itu berlaku tak ada celebration, tak diberitahu. Kerap berlaku kerana rotation of the earth tidak sekata. Bila berlaku, you are physicist kan, you tahu conservation of angular momentum. Bila berlaku misalnya volcano eruption, the density of material, distribution of material dah berubah, the speed of rotation berubah. So sometimes it is faster, sometimes it is slower. So perkara itu diambil kira, di adjust. So now the Gregorian time ni is well taken care, dijaga dengan baik. Ada satu badan yang monitor speed of rotation, and from time to time terpaksa ditambah second, tapi ada juga from time to time dikurangkan so that dia tak lari. Itu. Jadi there's a lot of science behind it, a lot of science. Kemudian we go to lunar calendar. Lunar calendar, contoh yang practical still using yang I'm aware of is the Hijri calendar, kalender hijrah. Next is lunisolar. Lunisolar is a calendar that combine both. Lunar calendar is very good sebab you can see every day ada perbezaan. So early civilizations adopt lunar. But lunar calendar is 1 day short every month, approximately 1 day short every month. So in 1 year about 11 days difference from solar calendar. Solar calendar has been designed to follow the season. So when you have a calendar that is 11 days short, dia akan lari daripada season. So in order to prevent it from continuously lari daripada season, every 3 years ditambah 1 bulan. Itu dipanggil intercalation, ataupun dalam bahasa Arab nasi. Ada ayat Quran tentang ditambah 1 bulan supaya dia akan follow balik, dia akan sejajar balik dengan solar, and it can be used as guide for pertanian. Musim ni dah masuk, musim ni akan masuk dan sebagainya. The Chinese community pakai lunisolar. I'm not sure, but I think the Indian community also pakai lunisolar, but different ways of using, ada different kaedah. The Chinese, sebab tu kita tengok Chinese New Year, walaupun dia lunar calendar, dia tak lari daripada certain month, January and February je. Sementara hari raya, dulu sekarang ni dah bulan ni akan jadi bulan Mei, bulan Jun. Sebelum tu lewat sikit, dia changing and it will pass through all the season. So sometimes kalau latitude tinggi, sometimes in winter, sometimes in summer and so on. Puasa pun macam tu. It will pass through all the season. Because the Hijri calendar is a purely lunar calendar. Ada soalan? Belum. So the Hijri calendar is purely lunar atas perintah Tuhan dalam Al-Quran. Okay. The previous to that, the Arab Jahiliyah, before the advent of Islam, they were also using lunisolar. Until the lunisolar calendar makers, they play around with the calendar. Sebab dalam dunia Arab ada 4 bulan haram. Tapi kalau dia nak berperang, di bulan haram apa? Bukan haram makan, haram berperang. Okay, so kalau dia ingin berperang dan dah nak masuk bulan tu, dia masuk intercalate satu lagi bulan, so that dia boleh dia lajak bulan tu dengan dia tambah. So they play around with the calendar, and that's not good sebab dia tak systematic. Kalau kita nak follow balik tarikh pun kita tak tahu masa mana dia intercalate dan sebagainya. Berbeza dengan the Chinese calendar is systematic. So because of that, turun arahan perintah bahawa tak dibenarkan langsung. So we inherit purely lunar calendar from there. Okay, so what's the big deal about calendar yang orang kat sini ni boleh hari raya tak sama, orang Turki hari lain, orang Saudi hari lain dan sebagainya, boleh tak unify, bukannya internet tu, UNIFY, unify our calendar. So we may think, oh, this is a religious matter. Sebenarnya it is a science matter. That's why the tajuk is astronomy in service of community. Sebab astronomy is used to serve the community interest, the community requirement and the community needs, which sometimes dictated by religion. Masa mula-mula people do this kind of research tentang nampak anak bulan apa semua tu, memang some people who misunderstand say, buat apa you buang masa buat research, kita ni school of physics, buat apa you buat gambar ni? But actually no, we use the requirement of the community to do a purely scientific research. So USM was a pioneer in the research for anak bulan. This was conducted by my senior, Professor Muhammad Ilyas from the School of Physics. Siapa pernah dengar dia? Dalam dekat library pun ada buku falak. Bukan nak kata dia the first in the world. Previously, since the time of Baghdad in 900 AD, 900 Masihi, sudah mula. Before that, it was a simple method, tengok anak bulan, settle lah. But then the scientific mind sit down and said, can we predict this? So they have developed a method of prediction even that time. Tetapi after that, the decline of the Islamic knowledge, macam-macam lah sudah berlaku dalam tamadun Islam. The thing was quiet. Research lama kekal macam tu, tak ada new R&D, new knowledge. So our local Professor Muhammad Ilyas of USM, he is the one who rekindled, menyalakan semula api ni, dan sampai sekarang the research is ongoing. So why is it difficult? Antaranya previously is because the knowledge have not expanded, and that was the motivation why Professor Ilyas wanted to undertake this research dan nak selesaikan masalah ni. Masa tu saya tak tahu lagi tentang benda ni. So later when I interact with him, then I understand what he wanted to achieve. So he conducted research mainly on data yang sedia ada from Greece and so on. We collected the kumpulkan data and make a criteria. Okay, what we found out, what he told me as well, mainly what he told me, anak bulan ni is not the same as new moon. Okay, new moon in the astronomical definition is bila matahari, bulan dan bumi, bulan mengelilingi bumi, matahari, bulan dan bumi berada sebaris. Sebaris tu from one perspective lah, tengok dari atas. That is new moon. Tetapi kalau from the community perspective, the moon is not only born, it has to be sighted. Boleh nampak. And that usually do not happen after conjunction. Immediately after conjunction, tak boleh nampak. And we try to offer an explanation. Why is that so? And the answer lies in the human eye as the detector. Sebab nampak ni dengan mata manusia lah. Kalau kita bounce, kita hantar radar, kita bounce balik, bulan tu memang ada. Isunya bukan bulan tu ada ke tak ada. Bulan tu ada, cuma boleh nampak tak boleh nampak. The eye as a detector, dia require contrast. Kalau tak ada kontras, nampak sama je. Walaupun dua benda tu, kita letak dua keping kertas yang sama, one on top of another, tanpa kontras, tak nampak garis-garis semua, kita tak dapat bezakan walaupun dia dua item yang berbeza. Similarly, when the crescent is in the sky and the sky is bright, then the brightness of the sky swarm the crescent light. You may not realize this, you may know but not aware. At this moment, di langit ada bintang tak? Apa hujah you? Ada tak bintang sekarang? Ada kan? But you cannot see. Because why you cannot see? Why you cannot see? Cahaya matahari. No. Cuba tengok gambar kat bulan. Astronaut kat bulan. Nampak bintang tak? Padahal dia terang benderang, dia ada shadow semua. It's not just sebab ada matahari. It's sebab ada matahari dan ada atmosfera yang scatter the light of the sun, making the atmosphere glow. The atmosphere glow. And that atmosphere glow tu is brighter than the star. So, tak nampak star. The lack of contrast between the two. Kita nak tahu ni, contohnya kalau waktu malam kita bawa torchlight, kalau kita on, kita boleh nampak beam ni kan. Beam tu is because the light interact with the udara and some of it scattered. So kita boleh nampak bahagian tu bercahaya. Kalau kita in vacuum, that so called beam tu tak nampak. Dia nampak source dan destinasi dia. Okay. Similarly, when the new moon is born, the sky is bright, you are unable to see the moon. Okay, syarat untuk kita kata besok is a new day is that the moon must be born before sunset. Sebab in Hijri calendar, the day begins at sunset, bukan at midnight. The Gregorian system, the day begins at midnight. Actually kita boleh pakai mana-mana saja, tapi the Hijri tradition is the day begins at sunset. Sebab itu banyaklah hukum-hukum zakat apa semua dia begin from sunset. So after the sunset, the sky does not become dark immediately. Immediately after sunset, it's still bright. You can still read newspaper. You can still go about doing things. Eventually, dia slowly sampai when the time of Isya lah. Then baru dia betul-betul gelap. Okay. So when a newborn is born, if it is just born, dia baru separate from the sun. So dia macam tu, matahari, bulan, bumi. Okay. So dia baru move out sikit je. So dia very close to the sun. As we go sunset kat sini, kan bumi macam tu, gelap belakang gelap. So dia rotate anti-clockwise. So somewhere here kita nampak. So kita akan nampak matahari dan bulan sangat dekat. So when the sun set, bulan above, but very close to the horizon. Before moon set, it's very close to the horizon, and that time the sky is still very bright. So lack of contrast. So itu tak dapat detect. At the same time, when the moon is very young, the size of the crescent is tiny. So the amount of light reflected by the moon is tiny. And plus bright background. Dia tak nampak. Okay. There are other theories being offered also. Why tak nampak? That is the limit of our vision. This offered by some scientists. Dia kata yes, also because when the crescent is so thin, retina mata kita tak dapat resolve So as a result, memang tak dapat detect juga. So ada dua factors together combining. But the next day, the moon, dia take 30 days, 29 to 30 days to go one round. The next day, dia move about 13 degrees. So relative to us, dia dah pisah dengan matahari 13 darjah. And so its crescent is bigger. And 13 darjah means matahari dah terbenam, dia duduk di atas ni. So sempat matahari itu terbenam dalam sikit, the contrast gets better sebab the sky becomes darker and darker. So that's the time when it's possible to see. So usually about 24 hours after conjunction, after new moon ni sebaris tu berlaku, kita dapat lihat. But that's not say is as simple as that, because a lot of factor, environment, weather, cloud cover and so on affect this new moon. So far, the record in Malaysia has been about 15 hours. 15 hours, paling muda. The age of the moon after conjunction is about 15 hours. Maksud dia apa? 15 hours before sunset, the moon is already born. Sebab tarikh waktu bulan lahir dia bukan pukul 12 ke, pukul 1 ke. Every month dia different. Okay, sebab dia punya orbit is not exactly 29.53 days. Dia sekejap laju sekejap. So dia akan ada a certain time lah. So from that time sampai local sunset can be many hours lah. Can be 1 hour, can be 15 hours, 17 hours, 20 hours, so on. So throughout the experience of sighting, we find that 15 hours is minimum. So the moon has to be of certain age, but usually 24 hours. Besok baru nampak. So that is to me that is the astronomy of lunar sighting. That we offer an explanation and we offer the calculation and so on lah. Kita offer calculation tu di mana dia akan terbenam, di mana dia di langit. That require calculation. Dan kalau siapa ada peluang nanti anak bulan Ramadan ni kita ada cerapan dekat Balai Cerap Pantai Aceh. All are welcome. So bukan semalam bulan apa? Bulan Syakban. But this is untuk Ramadan. InsyaAllah disediakan makanan semua percuma. Memang digalakkan untuk orang sama-sama. Then you will see how the proses cerapan tu dilakukan. So there is a calculation. Then there is a theodolite yang orang guna untuk, and they have to adjust according to as the sun set. Dia punya theodolite tu, the moon will be here, somewhere here or exactly above. Dia akan ikut the sun. So the theodolite every minute dia akan tukar position, pointing at they track the moon, the new moon. We have to do that. Sebab langit ni terlalu luas. Once you are in the open, you know, nak tengok kat mana ni. Kan? And then benda terhalus, if you don't have an aid, payah nak nampak lah. Okay, so that is one area where astronomy is in the service. There's another area in timekeeping. We know when midday is. Kalau kita nak semayang pun kita tahulah after midday sikit. We know when sunset is, sunrise is. The most difficult of them is the time of Fajar, time of dawn. Because the time of Fajar is described as the presence of thread of light above the horizon. So we have to find when that thread is formed. So we are actually chasing for the thread. Right now we are doing R&D on this area. Bukan kita saja, almost satu Malaysia. And bukan Malaysia saja, satu dunia. I can show you many research in Saudi, in Jordan, in many countries. doing this research. Walaupun benda tu kita anggap settle, kata dah semayang berpuluh tahun baru nak buat research ni. But we need this research and we are conducting. The issue is when we see the threat tu jadi macam mana? The threat occur. Tak ada slide payah. You see the Earth, and then you see the atmosphere. The horizon is when kita blocked by the Earth. Kita tak boleh tengok bawah lagi dah. Okay. Tapi the Earth has atmosphere. So yang nampak threat tu is that layer of atmosphere about 2,000 kilometers away. Bukan yang dekat. Kalau kita observe dekat katalah Pantai Aceh, observatory Pantai Aceh, kita nampak that light. That light does not originate from Pantai Aceh. It originate somewhere about 2,000 kilometers forward. Matahari masa tu berada di bawah. Dia shine the upper atmosphere. The upper atmosphere glow. Kita daripada bawah ni, kita nampak. We capture that glow. So there is a great deal of science there that need to be uncovered and so on. Jadi saya aluk-alukan siapa nak buat research bidang ini. Okay, saya ingat that's enough for now. Yang thread no? Itu Fajar Sadiq. Okay, yes. So you want to ask about Fajar Kazib. Okay, also Fajar Kazib ni ada candidate dia. Maybe dulu kita salah faham ataupun saya tak tahulah macam mana, kita sangka Fajar Kazib tu originate due to the same mechanism as Fajar Sadiq. Fajar Kazib ni Fajar palsu. Fajar palsu ni dia kalau Fajar Sadiq dia thread macam tu, ini horizon, dia a thread above the horizon. Fajar Kazib is the light that goes like that. Dia vertical. Kalau higher latitude dia mungkin macam tu. Tapi kalau dekat equator dia almost like a hill gitu. Banyak description dalam kitab-kitab ada. For a time kita tak berapa faham macam mana terjadi. Ya. Boleh tengok. Ini kasih. Dalam in astronomy is called zodiacal light. Zodiacal light. So sekarang bila kita faham contributors lain from other bidang, zodiacal light. You know one of the famous rock band dekat UK, The Queen. One of them yang buat PhD ni on zodiacal light. Dia well educated. Walaupun atas stage dia lompat macam saya tak pasti yang tu. There is no, I mean, maybe we should cipta coin satu istilah for that. The general one is twilight. The general term is twilight. Tapi bila kita nak sebut twilight tu boleh misunderstand. Sebab twilight tu kadang orang tengok atas. Tengok dah mula ada kesan cahaya, twilight lah kan. Tapi sebenarnya yang kita interested is the specific twilight for the Muslim community lah. The twilight that is just above the horizon. Biasanya we need a sea horizon lah to see that.
Kira kalau nak tentukan yang Fajar Sadiq ni, bila kita kena tahu angle matahari dah.
Yes, this is more difficult sebab you have to know where the sun will rise. Because tak ada sun lagi. Kan? So you have to do your calculation, then you have to know your azimuth. Silap kira tu kita tengok tahun ni matahari terbit tahun hari. So you have to do some calculation before the observation. And then also susah dapat. Why orang tanya why is it taken so long? You tak reti buat research tu. The problem is most of the time kita punya horizon is cloudy, so kita tak nampak that first stripe tu. So we see later. So kita nampak later dah lewat sikit. So kita tak nak tu, kita nak the first light. The first light tu saya nampak sekali saja. When we do our research on an aircraft, we conduct one research under Persatuan Falak Syar'i Malaysia. Kita dapat grant daripada MAS dan kebenaran untuk duduk dalam kokpit untuk observe fajar. And tujuan dia ialah supaya kita develop satu jadual solat di atas kapal terbang. So at that latitude ada banyak unknown. Reflection, atmospheric reflection from high latitude kita cari dalam literature tak ada. We have to do our own measurement. And so we were up there lah. Jadi masa tu first time without cloud, you see a very beautiful. Memang ada tunggu. After that dah turun on the ground, tak pernah jumpa yang macam tu. But since I had the privilege, I know how it looks, but I cannot explain to everyone else. So semua yang pergi hari cerapan tu duk tunggu mana dia line tu, tak nampak. Because later bila dah matahari naik dah baru kita nampak, ada awan. Masa gelap, we do not know there is awan or not. Ya? Line tu is Fajar Sadiq. Online tak pernah dapat. Ya? Tapi kita boleh estimate dah, sebab even awan ada depan pun kita boleh nampak dah awan tu ada cahaya belakang. Tapi tak nampak lah line tu. So I notice ada researcher lain juga yang buat. Depa report betul. Dia punya finding tu astronomically sound. Tapi dia kata awan ada, kami nampak cahaya di belakang awan. So okey jugalah. And then fajar kazib is interesting sebab fenomena dia bukan related to dawn, but it is dust particles that is surrounding, ikut mengelilingi matahari. So bila matahari ada mengeluarkan cahaya, this dust particles semua bercahaya juga. So bila Earth nak masuk siang tu, dia face that one before matahari, before dia nampak matahari, dia nampak dust. So dia nampak as a line. So that's how we understand fajar kazib. And fajar kazib from that perspective means dia tak hilang. Dulu kita ingat fajar kazib nampak dulu, lepas tu dia hilang, lepas tu fajar sadiq datang. Itu andaian kita tak pernah tengok. Tapi once kita understand this perspective, sebenarnya fajar kazib tu ada saja, tapi cahaya dia akan diatasi oleh cahaya fajar sadiq dan lama-lama dia hilang sebab kontras dia hilang. Because this light start to grow brighter and brighter. Sebab fajar ni dia bukan fenomena daripada tak ada, ada. No. Dia sikit. You start to feel the light is start to come. Itu pun satu juga where you say the threshold that this light is now dah jadi fajar. Sebab ada orang lain mata dia lagi sensitif dan sebagainya, dia kata actually before pun dah nampak dah sebenarnya. 5 minutes earlier I dah nampak dah. Orang lain yang mata rabun macam saya ni, orang tua dah, dia kata tak lagi. Mana tak ada lagi. Kawan tu kata ada lah. So we have dispute. So how you decide? So saya propose satu kaedah. I said when you measure, you use instrument, you measure the brightness of fajar kazib, you get the value, pixel value dia. And then when fajar sadiq naik, dia naik sikit-sikit. When the two values match, kita kata that's the beginning. Maybe before that pun dah ada lah. Masa kami naik kapal terbang itu yang kami dispute tu. Ada tak ada. Masa nampak dah, tapi tak confirm. So kita tunggu sikit lagi. Then it gets brighter and brighter. Lepas tu that benang tu dia akan broaden and then light up the whole sky. Macam itulah. Okay. Anything else? What?
So what you subuh ni pada stahik ni kan. Kalau tengok mata kenapa kalau tetap standardize, kita tengok guna kamera. Kamera
Yes.
kita,
This is an interesting, tu ada satu suggestion that a properly calibrated camera boleh membantu lah. Sebab kita nak tunggu sana tiap-tiap pagi pun penat juga. Kalau kita pergi tempat, kita kena pergi tempat beach lah. Beach tu kena gelap. Kalau ada terang, ada elektrik apa semua tu dah dia ganggu lah. So kita kena pergi remote area. So pergi kan, penat lah kalau tiap-tiap hari nak buat macam tu kan. So why not kita just cacak satu kamera and then through internet kita download lah gambar dia. So that's a possibility. Ya, siapa berminat boleh create the technology untuk lakukan itu. Ini projek untuk master. Siapa final year dah? Akram boleh kot second master.
so yang tadi tu new moon kan. Kenapa kita tak standardize juga guna kamera?
Yes. Actually nowadays dulu nampak saja ada second person yang testify tengok kat situ, oh ya saya nampak dua orang, kita terima walaupun tak ada rekod. Sekarang ni we need photographic evidence as well. So maknanya kita dah mula rely on teknologi. Cuma ada caveat sikit sebab sambutan CCD atau CMOS berbanding dengan mata manusia tak identical. Some of this dia sensitif pada infrared. Mata kita tak nampak infrared. So ada kemungkinan dia nampak sebab dia punya julat sensitivity infrared kadang boleh tembus awan yang nipis-nipis lah. So that's something yang we realise. Itu not for us scientists to decide. Itu kita serah kepada bahagian fatwa, bahagian sana lah untuk say we accept your finding or we don't accept. Tapi kita boleh conduct research lah. We can conduct research. Itulah saya personally saya macam tu. Saya tak favor menggunakan enhanced instrument. Saya juga lihat ada grup di Universiti Malaya yang masa hari ceraphan tak nampak. Dia balik, dia ambil fotograf tu, dia image process. Dia guna algoritma ni sampai nampak. Maknanya boleh buat sampai nampak.
Tengok yang Prof dia punya PhD dia pasal sebahagian one of the topic is about new moon.
Yeah. So basically you can do image processing bagi nampak enhance.
It's not agree by
Itu not my decision. Saya terima saja apa yang kalau sebab tapi logik saya simple je. Kita bukan nak kata bulan tu ada ke tak ada. Kita tahu bulan tu ada. Cuma syarat tu dipenuhi atau tidak. Kalau kita enhance, jumpalah insya-Allah. Jadi tak payah pergi tengok pun. There is a possibility advancement in fatwa will accept that. Dan kita tak payah pergi cerap lah, kita just work beforehand, just do calculation lah.
Macam let's say kalau eclipse waktu sunset, itu dikira sebagai new moon.
Itu definition new moon. Tetapi bukan definition anak bulan. Sebab anak bulan masih perlu
kalau eclipse tu tak nampak, kira tak nampak lah.
Kira tak nampak lah. Tapi eclipse kalau dulu-dulu lah, zaman dulu-dulu tidak ada komputer apa semua, eclipse provide a very good input to computation. Nak tahu kata computation tu of conjunction, time of conjunction tu betul atau tidak, tengok sekali-sekala berlaku eclipse, you compare with your algorithm, sama tak? Kalau sama, then you know you have made the right calculation.
So yang mana kalau
Oh.
Kalau kita ada lunar, kita ada advantage and disadvantage, kita ada solar, ada advantage, solar tu ada advantage. Kalau yang ada ideal tu, kalender should be apa?
Timekeeping yang senang dibuat. So far semua kalender yang ada ni sesuai. Tapi kita kalau tengok the roots ni, Gregorian is Julius Caesar. Julius Caesar buat tu lupa nak cerita. Sebenarnya sebelum tu they were using lunar juga. And then the Roman people depa juga intercalate. Tapi intercalate sesuka hati juga. Julius Caesar tak berkenan. Dia kata no. Aku tak setuju ni. So his solution was go solar. In our case, we go purely lunar, they go purely solar. Tapi semuanya sebab campur tangan kepada urusan kalender yang tak sistematik. So then of course you can go in between lah, sebab you nak season, you nak your calendar bantu you in season. Farmers dia bukan nak buat calculation, dia nak tahu bulan ni bila dia nak harvest, bila dia nak cuk tanam kan. So then you introduce the additional month tu lah, supaya dia tak lari dengan season. Itu so, I think practicality lah.
Sebenarnya kalau kalender yang bagus, kalender yang boleh kita punya season lah. Yang records tu boleh
And of course calendar also allows you to go backward and see history, mencatat kejadian kan. Saya lahir sekian hari, so you can go back any peristiwa berlaku, First World War, Second World War, apa ni Alexander the Great conquer sana sini, bila berlaku kan. So you have a calendar tu, and also to chart out program in the future. Macam nak buat program hari ni, 2-3 minggu lepas dah ada orang booking dah tarikh kan. So also untuk merancang. So calendar is very practical and very important. Kita pakai Gregorian. So that's astronomy. Ada bukanlah susah sangat astronomy kan. Okey juga
time keeping dalam 7 minit second
okey.
Yang tu macam video kan.
Yang tu quite a recent discovery. Lebih awal daripada tu ialah the discovery of very precise frequency of atomic cesium transition tu, and that become the basis for atomic clock sekarang. So sekarang ni time is very accurate. Dia selalu masa bercakap ni dia bunyi.
Okay, lagi tak boleh? So,
okay.
Minggu depan mungkin ada terima kasih. Jenama apa? Oh, okey. Satu tahun tak tambah. 400 tahun tambah. Itu ada lagi. Itu dalam Gregorian.